Hello and welcome to Selection with Sathi. Today we take a deep dive into iterators and generators from Fluent Python Chapter 17. We'll cover the Iterator Protocol, yield, generator expressions, yield from delegation, and classic coroutines. These are fundamental to writing efficient, Pythonic code. The Iterator Protocol is built on two methods, underscore underscore it underscore underscore and underscore underscore next underscore underscore. An iterable is any object with underscore underscore it underscore underscore that returns an iterator. An iterator has underscore underscore next underscore underscore which returns the next value in the sequence. Every iterator is also iterable. It has underscore underscore it underscore underscore returning self. When there are no more values, underscore underscore next underscore underscore raises stop iteration. Why do iterators matter? Lazy evaluation and memory efficiency. A list of 10 million items consumes 10 million memory slots. An iterator produces one item at a time, constant O of one memory. Database cursors, file readers, and network streams are all iterators. Lazy evaluation means values are computed only when requested. Generator functions are the easiest way to create iterators. Any function with a yield keyword becomes a generator function. Calling it doesn't run the body, it returns a generator object, which is an iterator. Yield pauses execution and produces a value. The function's local variables and state are preserved between yield calls. Generator expressions are like list comprehensions but lazy. Square brackets build a full list in memory. Parentheses create a generator expression that yields items on demand. Use genexps for one-shot iteration, sum of x squared for x in range n. But remember, a genexp can only be iterated once, a list can be reused. Yield from delegates iteration to a sub-generator. It replaces the common pattern of for item in iterable yield item. But it's more than syntax sugar, it creates a transparent channel. Send, throw, and close calls pass through to the subgenerator. The subgenerator can even return a value that yield from captures. Classic coroutines use generators with send, throw, and close. .send of value resumes the generator and delivers the value to the yield expression. The first call must be next or send of none to prime the coroutine. .throw raises an exception at the yield point. .close raises generator exit to cleanly shut down the coroutine. These pre-async coroutines still appear in older Python codebases.
Let's build a sentence iterator. The sentence class splits text into words and implements underscore underscore it underscore underscore returning a separate sentenceiter object. Sentenceiter tracks the current index and returns words via underscore underscore next underscore underscore. When the index exceeds the word count, it raises stop iteration. Now for W in sentence, hello world yields hello then world. An arithmetic progression generator is a clean use of yield. The function takes start, step, and an optional stop. It uses a while loop, computing start plus step times index on each iteration. It yields the result and increments the index. Arithprog of 0, 0.5, 3 gives 0, 0.5, 1.0, 1.5, 2.0, 2.5. Lazy, infinite if stop is none, and works with any numeric type. The Itertools module provides powerful composable iterator tools. Chain joins multiple iterables, chain of ABC and definite gives ABCDEF, islice slices lazily, islice of count, 5 gives the first 5 values. Groupby groups consecutive items by a key function. These tools compose into lazy, memory-efficient data pipelines, process millions of records without loading everything into memory. Yield from makes recursive generators clean and readable. Our flatten function iterates over items. If an item is a list, it uses yield from flatten of that item, recursive delegation. Otherwise, it yields the item directly. Flatten of bracket 1, bracket 2, bracket 3, 4, bracket 5 gives the flat sequence 1, 2, 3, 4, 5. An averager coroutine demonstrates send. The function initializes total and count to 0. In an infinite loop, it yields the running average and receives a new value via yield. First, prime it with next. Then send 10, average is 10. Send 20, average is 15. Send 30, average is 20. The coroutine maintains state between send calls.
Key tips to remember. Keep iterables and iterators separate. One iterable should create multiple independent iterators. Use generator functions instead of iterator classes. They are shorter and clearer. Yield from is more than syntax sugar. It handles send, throw, and close transparently. Classic coroutines with send and throw still appear in legacy code. Understand the pattern. For more concept videos like this, download the Selection with Sathi app. Like and subscribe. Thank you.